This talk is about React 18 for external store libraries. It's for developers who develop external stores that interact with React. Such developers include public library developers, private library developers in companies, and even developers who create shared functions within projects who might not think of themselves as library maintainers. With that, let's start. Before diving into the talk, let me introduce myself. My name is Daishi Kato, and I'm from Japan. I have been using JavaScript from the beginning. I like open source, and my first JavaScript open source software is something I developed 9 years ago. It's a library to transpile code for tail call optimization. Recently, most of my open source projects are for React. It was when React introduced function components that I got interested. So it's quite natural that I'm a big fan of React hooks. There are many libraries with React hooks that I developed. Among such libraries, these are some popular libraries that I maintain. The first one is Zustand. It's a library to create an external store for React. It's a very tiny library and it's fairly predictable. The second one is Jotai. It's a library based on React context. You can define atoms, which are the PCs of your state. The third one is Varusio, which is a library to create a proxy state. A proxy state detects mutations and creates immutable snapshots that can be used in React. The last one is called React Struct. It's a library to provide what I call state usage tracking. It automatically avoids extra re-renders. All libraries provide basic features for global state. Global state should be carefully developed in React 18. What's new in React 18 is that you can opt into keeping the app responsive while rendering. This means that if you use a concurrent features like start transition, React can now render with pauses. This allows the browser to handle events in between instead of freezing the browser during rendering. This is called concurrent rendering. It's great, but it introduces a slight problem, which we will explain shortly. The good news is, most libraries work just fine. Only a few libraries are affected. They are libraries that depend on external stores. Most libraries are unlikely to depend on external stores. For example, if your library only uses React props, state, and context, it doesn't depend on external stores. And such libraries are not affected. So why do a few libraries got affected by concurrent rendering? A library with an external store is affected because tearing can happen. Tearing is a visual inconsistency that users can see. With the legacy root API, it wasn't a real problem because there was no chance for the external store to change during rendering. Before learning more about tearing, let's talk about external stores. So what are external stores? For example, Redux and Zustand stores are external stores. DOM objects are external stores too. A global variable can be an external store. Technically, date object is an external store. More precisely, internal things are props, context, use state, and use reducer. Everything else is external. In this sense, useRef can be an external store depending on the usage. In general, useRef should be carefully used. How can tearing happen in concurrent rendering? Let's look at this diagram. We have a naive external variable called count, and we have two components A and B. And suppose both components read the count variable. At first, the count is 0, and component A renders. Meanwhile, the count becomes 1 and the component B renders. After that, React commits the changes to DOM, and the browser paints on screen. And finally, a user will see the inconsistency. Component A shows 0 while component B shows 1. This can happen because React yields between A and B, and there's a chance that count variable can change. This is a naive example, but the same thing can happen with any external stores. Usually, external stores have a subscription mechanism. and tearing happens only temporarily. If that behavior is acceptable, a user-learned solution may work. The behavior may not be acceptable or may not be ideal in performance. To solve the problem, React 18 provides a new hook called useSyncExternalStore. This new hook has an API that is familiar to developers who have experience with subscription. In its basic form, the hook takes two functions. The first one is the subscribe function to register a callback function. The second one is the getSnapshot function, which returns an immutable value. The value is then returned by the hook. Let's see how to use it. This is a small example to use the useSyncExternalStore hook. We have a naive store. It has a state variable and a setState function to update the state variable immutably. We have two more functions, subscribe and getSnapshot. The subscribe function adds a callback function to listeners. The getSnapshot function simply returns the state variable. We can ensure immutability by freezing objects. If the objects are nested, you won't freeze them deeply. It's fine to skip freezing if you are sure about the immutability. Now, with those two functions, we can use the useSyncExternalStore hook. It's pretty straightforward. You get a snapshot variable, which you can use like the state variable returned by the useState hook. Before diving into the demo, let's introduce a package. The useSyncExternalStore hook is only available in React 18. To help the migration, React provides a new package, useSyncExternalStore, the same name with hyphens. This package has a shim, some compatibility code that runs in React 17, and the previous version that supports hooks. The hook in the shim automatically uses the React hook in React 18 and the shim code if it's not available. So it's recommended to use this package if you need to support both React versions. It's time for the demo. Let's learn how to migrate using a small example. First, before learning how to migrate, let's take a look at the contrive example to understand the problem. As you see, there's a custom hook called useMouseX. This hook returns the current mouse position X. It's implemented with useRef and useEffect. useRef defines a ref that holds the X value. Inside useEffect, we define a callback that updates the ref value. Then subscribe the callback to the mouse move event with add event listener. As I said, this is a bit artificial, but this hook looks valid and it may look familiar to some people. Now the next is the mouse position X component. It uses the useMouseX hook and renders the X variable. Notice two extra lines. It loops for 20 milliseconds. They emulate heavy computation. It helps to reveal concurrent rendering behavior. The last part is the app component. It has a count state created with useState. The inc function is to increment the count state. The app component renders the count value, a button to increment the count value, and 50 mouse position X components. Now let's see how it behaves. If we click the button, the component re-renders and it shows the latest mouse X values. It works as expected. All values are consistent. Let's see how it behaves in concurrent rendering. To enable concurrent rendering, we use star transition. Import star transition from the React package. And inside the inc function, we wrap the setState invocation with start transition. Let's check the behavior. We click the button and immediately move the mouse pointer. Because of the heavy computation, the mouse pointer moves while rendering. In concurrent rendering, there's a chance that the ref value is updated during rendering. As a result, we observe inconsistent mouse X values on screen. This is what we call tearing. This happens because we read the mutable variable in render. Is it surprising? This only happens in concurrent rendering. So you may think if you don't use start transition, it's safe. While it's partially true, the point we want to make here is, from the library point of view, we cannot ensure that. In this case, the useMouseX hook is a library. The implementation of useMouseX has nothing to do with start transition. Developers can use start transition in a component very far from the place they use the useMouseX hook. Start transition is a nice feature in React 18, and we don't want to discourage using it when appropriate. That's why we encourage library maintainers to prepare for it. Since this example was a demonstration only to explain the tearing problem, let's move on to the next example where we learn how to migrate to use sync external store. The next example is a realistic one for global states. In this example, we implement a bare minimum store for global state. The first part is library code. CreateStore is a function which takes an initial state and returns three functions: getState, setState, and subscribe. It creates a reassignable state variable in the function scope. GetState is a function to return it. SetState is a function to update the state variable. It should update the state immutably. SetState will invoke all listeners. Subscribe is a function to add a listener. It returns a function to unsubscribe. It's pretty basic, but it's a ready-to-use store creator. Another piece of the library code is a custom hook to use a store. We have the use store hook below. The use store hook takes two arguments, store and selector. It uses use state and use effect for subscription. It returns a state, which is a result of the selector function. This is probably one of the simplest use store hooks. There must be many variants of this. For example, some of the variants may use useRef. This useStore hook is for the store created by the createStore function, but any subscription-based custom hooks should be similar. Like the useMouseX in the previous example can be implemented similarly. Okay, we've done with the library code. Let's look at the application code that uses the library code, that is, createStore and useStore. We create a store with an initial state object. The following is the counter component to show a count and a button to increment the count. It uses the useStore hook. We pass the store and the selector function to the hook. We need use callback in this case for the selector, because the selector is used in the useEffect dependencies. The following is the text box component, which shows an input field for the text property in the store state. At last, the app component simply renders the components we defined. We have components duplicated for the demonstration purpose. Let's see if it behaves as expected. If we click the button, it increments the count. If we type something in the text field, it updates. Now, app developers may use start transition somewhere in the code. And as we saw in the previous example, it may lead to tearing. So we want to make our library code to handle it. It's time to use sync external store. We use the package version with a shim, which works with React 17 and React 18. We import sync external store from the package. All we have to change is the use store hook. Instead of use state and use effect, use sync external store does the job. The first argument is a subscribe function, which in this case is store.subscribe. The second argument is a get snapshot function. We should use callback in this case, returning the selector result with store.getState. And that's it. All set. Let's check the behavior if it works as before. Clicking the button and typing in the field. It works just fine. Let's look at the useStore implementation again. It's far less code than the previous version with useState and useEffect. This allows us both safety in concurrent rendering and maintainability for subscription-based data source. We can encourage the use of useSync external store as a pattern, even if concurrent rendering isn't the issue for you. If the community moves to this new pattern, we will learn more about best practices and we can fix some potential bugs. I hope this shows how easy the migration is. With that, let's go back to the slides. Let's revisit what external stores are. As we define, external stores are something that doesn't fit in internal state. The internal state is basically use state and use reducer. This definition is precise but not very helpful. Let's see from the other end. From the perspective of use sync external store hook, an external store is something you can subscribe to. This can be module scope variables, DOM states, server cache data, or anything. If you use such external stores, it's very likely that use sync external store hook helps. If you are currently using external stores in React 17 or previous versions, you are probably using useEffect and useState, or you might be using useRef. All such use cases are recommended to migrate to use sync external store. And it's fairly simple. Your code will be smaller and more maintainable. There are a few things that we didn't cover in this talk. First, getServerSnapshot is an optional function that you can pass to use sync external store as the third argument. It is used in server-side rendering. Second, use sync external store with selector is a utility hook provided in the package. It accepts the optional fourth argument with which you can specify a selector function. Unlike getSnapshot function, the selector function doesn't have to be stable. This means we can omit useCallback, which can help existing APIs to migrate. And last but not least, in some use cases, useState and useReducer may work well enough for external stores, and sometimes desirable because they are more primitive hooks. We hope to discuss more patterns in the future. Let's wrap up the talk. React 18 introduced a new feature, concurrent rendering. Traditional solutions for external stores may not work in some edge cases. To this end, React 18 provides a new hook called useSync external store. There's a package with the same name, which also works with previous versions of React. Library maintainers are encouraged to consider migrating to the new hook from today. This is not only for public library maintainers, but also private library maintainers within a company, and even developers who maintain custom hooks or custom components. Let's get ready for React 18. With that, it comes to the end of the talk. Thank you. Bye.